there. Welcome back to Mr. P Helps with Geometry. This is Unit 1, Topic 1, Lesson number 4. So this time we're going to be writing notations when given information about a diagram. If you watched the last video, it's pretty much the exact reverse or opposite of that last video. So we're given a diagram this time and we're going to write what we see, or writing using notation. All right, it says determine whether the points can form a line in a given plane. Then write yes or no. So pretty simple. It says points R and S. Can we connect these points using a line on the plane? Yes, we can. And the reason why is because both points R and S are within the plane. So you can connect them. Remember, planes, the picture we make is a fixed size, but really planes go infinitely in all directions, just like a line. So if I was to connect them, it would look like this, and both the plane and the line does go infinitely. So that does work. Points M and N cannot be connected because point N is not on the planes, on the same plane. So that is a no. Points A and B are on the same plane, so that one is a yes. You can clearly see basically what it comes down to is the point inside the plane, therefore it's contained on the plane. If it's outside the plane, then obviously it's not on the plane then. Draw and label each of the following 3 collinear points in plane A. So I'm going to draw myself an A, my italicized A the best I can. 3 collinear points, so I'm going to call this point B, call this point C, and call this point D, and then show that they are in a straight line. If not all 3 points are on the same line, then they are not collinear. So that's why I need the line to prove that they are in a straight line. If you just draw 3 points that look like they're in a straight line, you technically have not proved it. 3 coplanar points in plane C. All right, so once again, here's my plane C, and I'm going to go with A and B and D. And it really doesn't matter where you put the points as long as you're putting the points inside the plane that you drew. All right, so once again, we are going to be, let me move my picture here down. So for number 1, we're given an illustration, and we're going to write the information that the diagram gives us, which is the opposite of what we did in the last video. So this is segment UT is congruent to, and we know that because of the 2 marks on both of these, segment SR. And that's it. Question number 2, the information they give us is this right angle. Now, what does that right angle tell us? That tells us that CE, line CE is perpendicular. That's the symbol for perpendicular. So you just have to remember all those notations that we've done in the last 2 videos to line CB. Be careful and make sure that you're putting line segments correctly. If I put in arrows on these, that'd be wrong because these technically are not lines. If I put in segment here and segment here, technically I guess that still would be okay. But because I could just use part of the line in order to denote this perpendicular, but I'm going to use the whole thing. All right, question number 3, we've got these 2 angles are congruent. So we have BCD, angle BCD is congruent to angle CDB. This angle CDB, remember you write the angle the same way you would connect to form the angle. So now I could have said BDC or CDB. The same thing backwards is the exact same angle. As long as the vertex has to be in the middle. And this angle has D as the vertex. Number 4, we're given 2 parallel lines. So I would say line FE is parallel. That's a symbol for parallel to HG, and that would be line HG. Question number 5, looks like they give us 2 things. They give us these congruency marks. So segment US is congruent to segment SR or RS, doesn't really matter. But then it also gives us this perpendicular symbol. So that means that UR, segment UR, that's all the way across. I could have just said US, but UR is perpendicular to segment ST. All right, question number 6. Once again, we have two sets of information given. We've got these parallel symbols. So that would be line S is parallel to line, and it's a little hard for me to see. It looks like line T, lowercase t. And then we've got a perpendicular symbol. So we've got line R is perpendicular to segment DC. And that would be this symbol. This segment and this line are perpendicular to each other. All right, question number 7. Once again, let me move myself. Looks like we have a bunch of information here. We've got congruent sides and congruent angles. Remember, congruent angles, as I said in the last video, can be shown different ways. This is one of those ways, using different amounts of markings for the angle. Or you can put little slashes on the angle. They're both ways of denoting congruent angles. So starting with the angles, we've got angle VTW is congruent to angle XTW. And then we also have two congruent sides, so that's VW, and that would be segment, is congruent to segment VWX. All right, over here we've got congruent sides, and congruent angles again. So let's start with angles. So angle DEF, that's this angle, is congruent to angle CFE. And then over here we've got angle, side, EG. And I'm going to call that line. Actually, it doesn't really matter. In fact, I'm going to call it segment. It is a line, but I'm just going to choose just to use this segment. No, sorry. I thought this was perpendicular. No, I have to use segment here. So GE, that segment GE is the same as GF. All right, it's very important that you are think about what you're looking at. Sometimes you can get confused very easily. So make sure you double check and make sure that you are denoting it with the correct notation, whatever terminology you're using. Write if the statement given is indicated by the marks on the diagram. So is this CD is parallel to EF? Yes, it is. Right? If the statement given is indicated by the marks on the diagram. So yeah, it is. I would say that there's more to this, to be honest, though, because I would also say that CE and DF, CE is congruent to DF. So this information does not say everything that's given, but it is correct. It is true. That's why I put a check next to it. VU is perpendicular to RU. No, in fact, our segment RU does not even exist in this diagram. So that's a no. So this is actually denoting SR being perpendicular to RQ. Now I could also say that this line SQ is, line SQ is also parallel to line UT. All right, question number 11 says angle VWU. V doesn't even connect to W, so that's not a possibility. Let's see. We have a lot of information given here. So we've got parallel lines. So we could say UW is parallel to VX. We've also got congruent segments. So UW, that's a segment, is congruent to VX. And it looks like we also have a perpendicular. So we could say VX is perpendicular to UV. So a lot of information provided in that one. HG is congruent to CD. HG is right here, and CD is right here. So yeah, I would agree with that. It's not all the information, but it is one of them. I would also denote the fact that GE is congruent to DE. And those are noted with the 2 marks. All right, and our last page, so we have DCE, D to C to E, so that's this one, and HCG, yes, I would agree with that. That is a true statement. There is more, but I think I've done enough of those kind of examples. Segment UQ, unless I'm blind, I don't even see a point Q on this diagram, so that's going to be a no. And YP, I don't see a Y or a P on this diagram either. So that's going to be no. List all the information. Okay, so now it's actually asking us to list all the information, even though I have been doing it. So we've got congruent angles. So UST is congruent to angle UTS. Okay, so that's the angles. And then we've got these parallel lines. XV is parallel to UT, line UT. And then we've also got a perpendicular symbol. So segment XW is also perpendicular to VW. All right, number 16. Once again, we got a lot of information here. We've got congruent angles, we've got congruent sides, and we've got perpendicular segments. I'm going to start with segment FE and ED are perpendicular. Now, notice I said ED. I could have said GD. How big that segment is doesn't really matter because however you write it, it's still going to be perpendicular. GE is also a congruent segment with the 1 marks to DE. And then we've got the angles. HGE is congruent to CD. All right, number 17, we've got parallel lines. So FD is parallel to EC. And then we've got, okay, there's a lot of information here. So we've got FE is also parallel to DC. So we've got 2 sets of parallel sides. Then we've also got a perpendicular. FD segment is CD is perpendicular. And then we got one last thing, which is FD is congruent to EC. A lot of information. All right, now last one. I know I'm running out of time, so we've got FEED. I wasn't going to write it, but I think I have enough time to do this last one as well. So we've got segment ED is congruent to segment GF. We've got perpendicular, so I can't see what that is right there. I think that's line V. Line V is perpendicular to segment GF. We've got angles, so that would be angle FED. And that is congruent FED to CDE. Angle CDE. All right, sorry, I know I'm getting a little sloppy here. And I got one last thing to fit in here somewhere, and that would be that line EF is parallel to line CD. All right, so 4 things in here. We got congruent angles, congruent sides, perpendicular segments, well, segment to a line, and then we've got parallel lines. So a lot going on in that question. I think I've pretty much run out of time. Thanks again for watching, and I'll see you in the next video. Please give it a like if it helped you learn anything about how to write the notation for perpendicular, parallel, and congruent sides and angles. Have a great day.